Hello everyone, welcome back. This is Compact Redstone 1-3, Basic Terminologies. I'm MU222 and as the title suggests, today we're going to go through some terms that you would come across when doing Redstone. So without further ado, let's get started. So this video will cover a lot of terms and their definitions. And the first definition is obviously piston door because we are doing piston doors. Which is also the main thing I'm targeting in this series. So what do we mean by a piston door? Well, a piston door is some amount of circuitry that upon being activated either places a set of blocks into a hallway or tunnel, and we call this as closing, or remove the set of the blocks from the hallway or tunnel, and we also refer this as the opening. So basically a piston door has to close and open. Very trivial. And normally, a piston door would perform both closing and opening and is reusable infinitely because this is also one of the rules that you have to follow. If it's not reusable infinitely, then it is not is basically not eligible for records, we say. Basically, we say it's not legit. But yeah, anyways. And one key thing about piston doors is that piston door, obviously you need door blocks, and surrounding the door blocks you would have the door frame. So we have the door frame blocks, and the door blocks of a piston door are usually solid blocks except with further restrictions. For Redstoners, we usually would use quartz block to indicate the piston door frame and the door blocks. But then for some doors like glass doors and TNT doors, well, you can't really have any quartz as the door block. So for the glass door, you would have glass as the door block. And for a TNT door, it's even better because both the door frame blocks and the door blocks are all TNT. So, yep. If there are any further restrictions, then we would not use solid blocks for the door blocks or the door frame blocks, or both. So, yeah. Now we come across with a bit more technical terms, which is redstone tick. Now I basically have touched it before, but then I will still talk about it now. So one redstone tick refers to 0.1 seconds in real time. This also means that 10 redstone ticks is equivalent to 1 second in real time. The short form of redstone tick used by me is either tick or just T. Sometimes T would usually be used in some documents, I think. I normally would just pronounce it as tick. So yeah. Now we come across to game tick. So one game tick refers to 0.05 seconds in real time. This means 20 game ticks is equivalent to 1 second in real time. This also means that 2 game ticks is equivalent to 1 redstone tick. And the short form is just GT, although I would still pronounce it as game tick, obviously. Now we come across with size. It is important for us to understand what size exactly means because we usually calculate, for example, the volume of a door. And we also need some expressions to show which kind of door in what magnitude we are building. So size is basically the cross-sectional area or volume of the door inside the door frame. And the size of the door can be expressed in one of the following terms. This might look complicated, I'll explain it later. So we have the first one, which is m by n, where m is the width and n is the height. We also have an m wide or n high. So it's quite vague for these terms, but I'll explain it later how you would apply them. Now for volume, it's usually expressed by m by n by k, where m is the width, n is the height, and k is the depth. So what are the 3 points, basically, how you would use them? Well, we can take a look at an example. So we have, for example, a 3x5 piston door. This uses the m by n term. And next we have, for example, a 1 wide conditional double piston extender lamp swapper. It's quite a long name. But then basically you will see m wide, so this matches with 1 wide. So we basically require the contraption to be in 1 wide in terms of its size. So yeah, and then we also have another application, which is, for example, a free high expandable door. So this uses the format of n high as to free high. So what this means is that we would have a door that is expandable, maybe infinitely, maybe not, maybe finitely. So, but the door would be 3 blocks in height. So basically, you can, for example, have a 15 by 3 door from the expandable door because it's expandable. So you are able to expand the door such that you can build, for example, a 15 by 3 door or a 12 by 3 door from this expandable door. Hence the word expandable, by the way. So this is how we describe what door we are going to make or what extender we're going to make, because we don't necessarily have to create piston doors. We can also create piston extenders. They are still a very popular category sometimes. But then for volume, I usually like to use an alternative definition. So the formal definition, as I've shown before, which is that M represents width, N represents height, and K represents depth. But for alternative definition, there are 2 cases. For standard doors, M would represent the length instead of the width, N would represent the height, it's the same, and K would represent the width instead of depth. And for ceiling trapdoors, and sky doors, M would represent the length, N will represent the width, and K will represent the height. Now, although there is a difference in word choices, M, N, and K still represent the same thing for standard doors. So it's just basically the different use of words. So in here, you can replace the word width with length and also depth with width. So yeah, even though we basically have changed the wording, what they mean is basically exactly the same. And for ceiling trapdoors, and sky doors, the meanings of N and K are swapped, basically. Like you see here, width represents the K depth here, and then the K represents the height, which should correspond to N represents height in the formal definition. And throughout the entire course, I would use the alternative definition unless otherwise specified. There is some good reasons why I choose to use this alternative definition. So, width and depth can be interchanged for ceiling trapdoors, and sky doors. And the dimension expression may become untidy as there is no restriction on the choice of width and depth. And using width and depth can basically make things confusing, as we usually consider length and width for a rectangle expression. Like this is basically how your math teacher teaches you. The longer side would be the length and the shorter side would be the width. So this also hence say length must be greater than or equal to width for ceiling trapdoors, and sky doors. This also tidies the dimension expression. And for standard doors, width, which is correspond to depth for formal definition, is usually the shortest. And for ceiling trapdoors, and sky doors, height is usually the shortest. And swapping the meanings of N and K automatically puts the smallest number at the end for better comparison and visually appealing. A great example would be to take from one of my doors. This is the 672 block 6x6 seamless, slimeless, full flush cave trapdoor. If we use the formal definition, we will write this as 12 by 4 by 14 or 14 by 4 by 12. Now, you can see why we write it like this, because we can choose width and depth interchangeably. So I can choose 12 as the width, 14 as the depth, or I can choose 14 as the width and 12 as the depth. And then we obviously have 4, which is the height of the door. But then for alternative definition, we will only have one expression. This is 14 by 12 by 4. Because 14 would be basically greater than 12, so we consider 14 as the length, 12 as the width, and 4 as the height, obviously. And then because we are using the alternative definition, we automatically put the smallest number at the end. And you can see it basically decreases to the right. And it basically makes better comparison and visually appealing. Now, the choice of using formal definition or alternative definition of size, especially for volume, basically, isn't really too much of a deal, because I don't really use volumes too much throughout the series, I think. But even if I use them, you can still basically compare quite easily, because it's just basically three numbers multiplying together. So it doesn't really matter too much. But here I'm just going to explain it in detail. Now, talking so much about volume and the choice of using some definitions for volume, it's time for us to calculate the volume. Now, here I have included a few examples with extenders mainly. So these two screenshots would represent a double piston extender that occupies 6 blocks. Now, one thing to note is that the input device, for example, this stone button, and the blocks occupied the extension of the extender do not count. So basically, you would see this double piston extender, it will extend the quartz block downwards, right? Now, those blocks we do not count towards the volume. And hence, we have 3 by 2 here, which is 6 blocks, and also 3 by 2 here, which is 6 blocks. And then we also have this case. This case is 9 blocks, because the quartz block is needed to support the repeater here. So this quartz block would count towards the volume. So this would be 3 by 3, which would be 9 blocks. Now, you might think, well, basically, if we have this quartz block here, but then wouldn't this quartz block also count? Because in the next example, it will be quite a bit apparent. So we have this double piston extender here. This is a pressure plate, and inside there's a minecart. So this is 8 blocks. Again, we don't count the lever. So this would be 2 by 4, because the quartz block here is needed to power the bottom sticky piston. Now, some people might think, hey, this observer also powers this quartz block, so shouldn't this be counted? The answer is no, because we are not powering any redstone component via this quartz block. And it's not necessary for the quartz block to even exist here. So this only counts as 6 blocks. Another very interesting feature of counting the volume is actually somewhat this thing. This is 20 blocks, not 16 and not 15. The reason is that we need the air blocks here and here. They are needed for the redstone blocks to extend. So basically, you have 4 here, because you still need this air block even though when this extender is extended, and we have 5 here because you still need this air block for this redstone block to extend. And this also applies even though if the redstone block or some other components, some other blocks that may be extended and retracted for a very short amount of time, it will still count because you still need the air block here. So just remember that whenever you need air blocks outside the contraption to work, that block also has to count towards the volume. And then we come across another thing, which is door patterns and shapes. Now, basically there are many door patterns and shapes, and it's impossible for me to cover through all of them. So I'll introduce 2 of the most popular ones. They are funnel and cave. But then the formal definition for all doors, patterns, or shapes would require some complex mathematical expressions. So I will skip the definitions and only provide the examples for you. So here's the example for funnel. You can see this would be the 2 by 2 funnel, this would be the 3 by 3 funnel, 4 by 4, 5 by 5, 6 by 6, 7 by 7. And you can also see there's a special case for the 2 by 2 funnel door. It uses stairs to create a pattern. Yep. And double-sided funnel doors are called vault doors. So please do not mix up funnel doors and vault doors, because it has always been a trend for people to mess up between funnel doors and vault doors. While obviously people do not really care about terminologies out there, but then if you're going to be a more professional redstoner, then you should be able to identify between funnel doors and vault doors. So basically what I mean by double-sided would be that you would have this exact pattern on the other side. So if you're facing towards this side and you go to the back, you will also see this pattern here. So this is what I call as double-sided. And then the example for a cave door is like this. It's quite a special shape as well. And you can see it's also symmetrical. So this would be the 3x3, this would be the 4x4, 5x5, 6x6, 7x7, and 8x8. So yeah, you can see how the pattern would go up and expand. So yeah, it's quite trivial still. Now moving on from door patterns, we would come across with some restrictions of doors. I will introduce 3 restrictions to you because otherwise this video would take too long. And one of the restrictions would be flush. So what do we mean by flush? When the door is closed, the outermost block aligns with the ceiling or the wall or the floor. So semi-flush would refer to doors that are flush with the wall, but with wiring below the floor. If there's no wiring below the floor, the door would be full flush. And all trapdoors that are flush must be full flush. So here would be an example of what do we mean by something that is flush or not flush. So we would have, for example, this open state for both of the doors. If the door happens to be not flush, then it would have this thing. And then if we add the wall and the floor, you will see this is indented. So this would be not flush. But then if it's flush, then we would see the door close up like this. And then if we apply the wall and the floor here, you see we basically can't even see the doorway. Hence the word flush exactly, because it's literally hidden. And now if for this case it would be semi-flush because we have the floor, but in case if we remove the floor and the wall can still expand downwards and there's still no wiring, then this would be full flush. Now we move on to seamless. Seamless is basically that there are no visible redstone components inside the door frame. But then seamless can still get a bit more complicated because there are 4 types of seamless. There is super, full, semi, and quartz seamless. And all 4 types require seamless on the front side of the door when we close it. Now, basically you would see these descriptions as like a stair. So each restriction would require even more. So super full and semi-seamless would require seamless on both sides of the door when we open them. And super and full seamless will require seamless on both sides of the door when we close it. And lastly, super seamless will require seamless on both sides during a closing and opening. So if you can see, it's increasing in terms of the restriction. Now, for redstoners, we usually want to compact our wordings as much as possible. So instead of saying full seamless, semi-seamless, so on and so on, we want to just simplify it to just say seamless. But then we still have some hidden roles when we say seamless. And normally for standard piston doors, so what do I mean by standard piston doors? So it would be like a 1 wide door and it is not flush and it can be square or rectangle shaped. Seamless door would usually require full seamless. But then for others, for example, maybe a funnel door or a cave door, then seamless would only require semi-seamless. So you only need to have the front that is seamless on closing and opening. But then for the back, you only need seamless when the door opens, not closed. And even when we say it's non-seamless, the door usually requires quartz seamless. So at least the door has to be seamless on the front when closed. So yeah, that's also a very interesting thing. Now let's move on to the next, a very simplified example. So seamless, we have a closed state like this. If the door happens to be non-seamless, you might see, for example, like a sticky piston head right here. But then if it's seamless, you will see basically nothing, just quartz block. And now we move on to the final restriction, which is hipster. So there are three types of hipster doors. We have the floor hipster, we have the wall hipster, and we have the ceiling hipster. So full hipster would require all the circuitry to be behind the floor or the wall or the ceiling respectively. So it depends on whether your hipster door is floor hipster, wall hipster, or ceiling hipster. Then you apply these words accordingly. But then semi-hipster would require all the circuitry to be behind or on the floor or wall or ceiling respectively. And by definition, all hipster doors must be semi-flush. So let's take a look at the example. Here shows the first semi-hipster that I'm going to show to you. So I just placed these white stained glass to help you identify where the wall would be, because you usually will add a wall here. So the closed state, we will see these two blocks come out. So these four blocks come out. And then we can see these two pistons are still here. Obviously, you can hide them if the white stained glass is replaced with some sort of blocks. And then when we open it, you can see these two pistons are still here. And then the wall blocks, if you wish, you can still place here. So this is the first kind of semi-hipster. You can see that these pistons here are on the floor level. Hence the word semi-hipster. Now, on the floor level doesn't necessarily require to be inside the wall. It can be outside the wall and just on any block of the floor, literally. So we have this here, for example. We still have this closed and it seems perfectly seamless, but then when we open it, we see these two normal pistons. So we see these two sticky pistons here. And this hence would be another case for semi-hipster, because we have some circuitry on the floor right here. And for full hipster, we basically have closed state, seamless, open state, seamless. On both sides, actually. So you can see the difference, hopefully. And I'm just going to cover all of these terminologies for now. Obviously, there's still a lot more terminologies that I would like to cover, but it is not quite useful for your basic understanding. If you still want more knowledge on terminologies, well, you can check out my other videos. I think there will be a 2-9, which is just on some terminologies, and 3-1 as well. That would be more on terminologies. It's because, quite frankly, there are some more complex terminologies that aren't really being used too much, but they are still quite useful. But if you don't want to just hear me talking about some terminologies, some selected terminologies, you want to know all of the terminologies, here's a useful list for you. You can always refer to these three lists. So this would be the introductory version of terminologies for people who have just started out. And then we have two more documents. One is the old one is the new one. And both of them are the full version of terminologies. So you can always refer to them if you want some more knowledge. And obviously, if you're still in doubts for any terminology usage, you can feel free to comment down below or just ask me directly. But anyways, that will be the entire video on basic terminologies. I will see you in 1-4 Redstone Ethics. So yeah, thank you for watching.